table in activity 3.5, one-to-one functions. In the activity, you will determine the inverse of a function using multiple representation. For each given function, determine the inverse using each representation. Complete a table of values for the function and its inverse. Sketch the graph of the function using a solid line. Then sketch the inverse of the function on the same color plane using coordinate plane using a different color. Write an equation for the inverse. All right, so first off, we need to complete this table. So to do that, we're going to do 3 parentheses negative 2 minus 6. It's going to be 3 parentheses negative 1 minus 6. 3 parentheses 0 minus 6. 3 parentheses 1 minus 6. 3 parentheses 2 minus 6. All right. All right, now let's graph those points. And we're going to graph this line in pink. Now, negative 2, negative 12 doesn't fit in the graph, so we're going to ignore this point. Let's start negative 1, negative 9, 0, negative 6, 1, negative 3, 2, 0. Okay, now, when we talk about inverses, we really need to graph the y equals x line. Okay, so 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. All right, now for the inverse portion, all we have to do is switch these values. So this becomes negative 12, negative 9, negative 6, negative 3, and 0. Okay. Again, we're going to ignore this point, but negative 9, negative 1, negative 6, 0, negative 3, 1, 0, 2. And let's go ahead and graph the inverse in blue. Okay. Now, to find the equation, step 1, we change f of x to y. So we have y equals 3x minus 6. Step 2, switch x and y. And then next step, solve for y. So we add 6 to both sides. So we get x plus 6 equals 3y. And then divide everything by 3. So the inverse function is f inverse of x equals x plus 6 divided by 3. All right, go ahead and finish up that page. All right, let's take a look at the next page. All right, first things first, we need to complete the table. So negative parentheses negative 2 plus 4, negative parentheses negative 1 plus 4, negative parentheses 0 plus 4, negative parentheses 1 plus 4, negative parentheses 2 plus 4. Okay, so now let's graph those points. So negative 2, 6, negative 1, 5, 0, 4, 1, 3, 2, 2. And let's graph that in pink. Okay, and again, whenever we talk about inverses, we always want to graph the y equals X line, so 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Okay. Now for these values, it's simple to switch, so this becomes 6, 5, 4, 3, 2. And we're going to graph this in blue. So 6, negative 2, 5, negative 1, 4, 0, 3, 1, 2, 2. Okay. Now let's find the inverse. So first step, change g of x to y. So y equals negative x plus 4. Switch x and y. So x equals negative y plus 4. And solve. So subtract 4 from both sides. X minus 4 equals negative 1y. Divide everything by negative 1. So that's 1x divided by negative 1 minus 4 divided by negative 1 equals y. Well, that's negative x plus 4 equals y. So the inverse is f inverse of x equals negative x plus 4. All right, go ahead and finish that up. All right, let's take a look at the next problem. All right, well, this is easy. H of x equals 2. So no matter what x is, it's always going to be 2. So 2, 2, 2, 2, 2. So again, let's graph this in pink. So negative 2, 2, negative 1, 2, 0, 2, 1, 2, 2, 2. Okay, and again, we always want to graph the y equals x line. So 0, 0, 1, 1, 2, 2, 3, 3. All right, and then the values switch. So 2, negative 2, 2, negative 1, 2, 0, 2, 1, 2, 2. And we're going to graph this in blue. Now, the inverse for this is in essence y equals 2, and the inverse is x equals 2. It's a unique case. Okay, go and finish up that. All right, let's take a look at the next page. All right, so let's go ahead and fill in the table. So absolute value of negative 2, absolute value of negative 1, absolute value of 0, absolute value of 1, absolute value of 2. Okay. So, and we're going to graph this in pink. So negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. right, again, whenever you're graphing inverses, you always want to graph the y equals x line. And then the value switch. So 2, -2, 1, -1, 0, 0, 1, 1, 2, 2. We're not going to get into the equation of this one. We're just going to look at the graph. And it's a little hard, so let me try to add the pink there. So you have the pink and then the blue. Okay. Let's take a look at the next problem. Right. So let's complete our table. So then parentheses -2. Anytime you square a number, you want it in parentheses squared plus 4. Parentheses -1 squared plus 4. Parentheses 0 squared plus 4. Parentheses 1 squared plus 4. Parentheses 2 squared plus 4. All right, so that's all right, let's graph those points. So -2, 8, -1, 5, 0, 4, 1, 5, 2, 8. Let's graph that in pink. And again, we always want to graph the y equals x line. And then inverse. This would be 8, 5, 4, 5, 8. Okay, so 8, -2, 5, -1, 4, 0, 5, 1, 8, 2. Let's graph that in blue. All right, now to find the equation, we change s of x to y, so y equals x squared plus 4. Switch x and y, so x equals y squared plus 4. Subtract 4 from both sides. You get x minus 4 equals y squared. You take the square root of both sides, plus or minus. Square root cancels the square root, so plus or minus the square root of x minus 4 equals y. So f inverse of x equals plus or minus the square root of x minus 4. All right, go ahead and finish that up. All right, let's take a look at the next page. How can you determine whether an inverse exists given a linear function? The only linear functions for which an inverse does not exist are constant functions. for all the linear functions an inverse exists. Can a linear function and its inverse be the same function? If so, provide an example. If not, explain why not. Yes, the inverse of any function that is symmetric about the line y equals x will be equal to the function. For example, for the function f of x equals x, the inverse is f inverse of x equals x. Also for the function f of x equals negative x plus 1, the inverse is f inverse of x equals negative x plus 1. All right, you can mark that out. Let's move to the next page. You can mark this page out. All right, you can mark that out. And let's take a look at here. Complete each sentence with always, sometimes, never. A linear function is sometimes a one-to-one function. An exponent function is always a one-to-one function. A quadratic function is never a one-to-one function. A linear absolute value function is never a one-to-one function. All right, let's take a look at the next page. All right, student Okay, student works 1A, 1B, 1D, 2A, 2B, 2C, 4A, and 4B. All right, go ahead and mark what I've marked out. Add the tables. All right, let's take a look at the next page. All right, you can mark out number 1 on this page. All right, go ahead and mark out what I've marked out. And then go ahead and add the tables that I've added. And then complete your assignment and have a wonderful Wildcat day.